All right. Corollary 1 basically says if I know two angles of two different triangles are congruent, then that third one automatically has to be congruent as well. So we just have to look at what we're looking for. So I'm looking for I'm looking for angle, or I'm given that these things are congruent. I'm supposed to show that C is congruent to F. So there's actually two triangles there. There's two triangles there. Let me pull them both out. And sometimes it's easy if you rewrite them as your two triangles. So I have A, C, E. And I'll pull out this guy down here that's on the bottom. And that is the A, B, F. All right, now the information they gave me was that B was congruent. So B was congruent to E. A has to be congruent to A, doesn't it? Reflexive property says x is equal to x. So that means A is equal to A. And I'm actually done. So I'm left with C must be congruent to F, because corollary 1 says all I have to do is prove that two of the angles are congruent, and the third one must also be congruent. So you're done. So like I said, the punchline was corollary 1. That was our answer, was corollary 1. We just had to break it apart to show that, yeah, I do know that two of the angles are congruent, and that third one is automatically going to be congruent then as well. Yes?
Could you have gone like angle BDC is vertical to angle EDF?
We don't have any vertical angles, actually. Oh, you're saying this one is congruent to that one?
Yeah.
You could, but I don't think it would help us.
Oh, okay.
We could say they're congruent, but it's not going to really help us, because in that case, I'd have to prove that this is congruent to that. Which you could, actually. Because you could say, since this is congruent to this one would be 180 minus this one's supplementary, it's a lot harder route, but you could go that direction. It's good to see that they're vertical angles, but it's much easier just drawing your two big triangles. But the big takeaway is, hey, look for overlapping triangles and see if they share a common angle, because those are automatically congruent. All right? So even though I don't tell you it's congruent, you have to know that when I pull these things apart, they are congruent. All right, questions on that? Yeah.
So like, so it's pretty much like the third kind of angle of the third, like, I guess point of that angle kind of helps make them equal. Like for ABD and ABD and AEC, like the C is the last, like, completes the triangle.
Yeah, and F completes this triangle kind of thing.
Yeah.
That they're the last angles left. They have to be congruent. All right, questions on this at all? All right, I would definitely have more in there than I wrote on here, because you should explain to yourself how it worked or why you have it. But you should have something written down, at least. I'm going to explain it. All right, questions on the homework? All right, Amber, I saw your hand first.
The last one.
The last one.
I got how you solve for x, but how do you then solve for y?
Oh, okay, then you just plug it in.
For any lesson?
Yeah, I'll show you. If you looked online, like I was talking about when you guys were leaving yesterday, I did, under the blank lesson, I actually right next to it put a filled in lesson that actually had these filled in. It might save you a little time, because you can just click on there and you can see it rather than having to scroll through a bunch of information, and then you know what box matches up. It could save you some time. So if you look at the blank lessons, I actually posted it in two places. I posted it with the blank lesson, and I also posted it in the solutions. I'll try to do that more, where I take a picture of my homework. If I forget, you know where to go otherwise. But I'll try my best to start taking pictures of it, because then you can just match stuff up. But this is exactly what was on there, and so this is exactly how I solved it. Maybe I'll take a picture of both. Just in case there's a question on 29 as well. All right, 100 and all of these are same side interior. I assume you did that,
Yeah.
right? So you know that they have to equal to 180. So this plus this has to equal 180. That's one of my equations, which I simplified down to 7x plus 2y. I need a secondary equation. Because I have two variables, I need two equations. So then I went ahead and I looked at, which one did I do first? I did this one first, actually. I did, how many degrees are in a triangle? 180, right? So I picked this plus this equals 180. That's this one.
I suppose I stopped because I was trying to plug it in for, that second equation right there, and because the y's cancel out, I wasn't quite sure
Oh,
how
okay.
to do it, but
Oh, I see.
any of them.
I see. Yeah, anytime we have two variables, we need two equations. Hold on one second. So my two equations I came up with was, hey, a triangle must be 180 degrees. So this plus this must be 180 degrees. So that was my first one I set up. The second one I set up is, hey, these two angles right here, this 100 degrees, and this angle right here, because they're parallel, are same side interior, so they must also equal 180 degrees. So I took this plus this, which make this angle, added this, which equaled my 180, which was my other equation. Lucky for me, this equation actually solved itself. So I had x equals 8. But then you have to take that x equals 8 and plug it in for this x value here to get your y. That's what happened here. I plugged, instead of this x, I plugged this 8. All right, Grace.
Oh, I'm just.
Okay, yeah.
I was wondering for number 29 and 30, why we can't do the thing out, so like where it's like they put the two equations and then you like, I forgot what it's called, but it's like you put one equation there and on the bottom you put like another equation and then you subtract it, and so it'd be like, for example, 2x plus y and then 5x plus y, and you stack them up. Oh, it's right there. Oh.
I did that.
Oh.
I did exactly what you described. The only reason why I didn't have to do it here is because I already knew x equals 8.
Oh, okay.
The only reason why we do that is so we can solve for a variable. So I did that exact same thing here. I came up with my two equations. My two equations for this one were, hey, once again, in a triangle it equals 180, so I should have this angle plus this angle plus this angle equals 180. And then we also know that this angle plus this angle must equal 125. Our remote interiors have to equal our, so those are my two equations. Just like you were explaining, I used elimination to solve it. You could also use substitution. All right, that's another thing. But I came up with my x and y values. Honestly, on the test, most of your points are, can you set up these two equations? And the remainder of the point or 2 points left would be, can you solve it correctly? All right, so the bulk of your points are, can you set it up? Amber.
So about the test, so since I was looking on chapter 3 is a really rather lengthy unit, so are we doing just one big test, or are we splitting it up into two small
We're done.
Oh, really?
Yeah. We have our test on Thursday,
Oh, that's right.
next Thursday, and then we're done. Yeah, we did it all. We did it all.
Sorry.
Yeah.
I'm really confused how 2x plus y, for number 29, 2x plus y plus 125 is 180.
And that's because I just said this angle plus this angle plus this angle has to equal 180 because it's a triangle.
I'm just looking at the wrong, I was looking at 2y plus.
Almost every one of these problems that have these missing things, at least one of them is your full circle equals 180, so you make all your angles equal 180. All right. Another key thing with these is you look at your remote exteriors, remote interiors, and your exterior. All right. Those are kind of the key to solving those almost every time. You can't. It's hard to hide it. All right. Other questions from the homework? This is online too, so if you don't get it all copied down, it is online as well. Yeah.
23, which like the ones that we were doing through in class.
Did we have to do? Oh, 23 from in class.
Yeah, but it was a part of the homework.
Yeah. All right, 23 is basically, do you know there's 180 in a triangle? Because all I'm going to say is, well, 60 plus 65 plus this angle has to equal 180. And that has to be 55. Well, I know this one's 50. This plus this has to equal 180 because it's a full line.
I missed that.
So that has to be 75, and that gets me my last angle. Is that good?
Yeah.
Okay. Other quick questions? Time for maybe 2 more, maybe. Yeah.
I missed the answer for number 30.
For number 30?
Yeah.
Like I said, it is posted online because there's a lot of work to have to copy down in class. It's posted online too. All right? So if you missed it, and if you can't find something online, hey, just email me. Like say, I know you said you posted the solution. Just email me and say I can't find it. I'll email it to you or just tell you exactly where it is on the Google Classroom. Okay? Other quick questions? Okay, cool. If other ones pop up, once again, come see me. All right, we're going to get into polygons. Polygon. Anyone know what that means?
Is that like multiple sides?
Yeah. Many sides. Or multiple sides. I like many because it fits in here better. That's all a polygon means. We're looking for things that have multiple sides. So that means a triangle is a polygon. It's got multiple sides. All right. So a polygon is formed by, and here's kind of the thing we have to do exactly. They are coplanar. They're coplanar segments called sides. And remember what coplanar means? It just means that they'd all lay against the wall or on the floor. They're all on one vertical thing. So like these are polygons. There's not one shooting out at us, right? They're all laying on the page. There's not one shooting out. They're not three-dimensional. They're just flat. That's all I mean by coplanar is they're flat objects. Each segment intersects exactly 2 other segments. One at each endpoint. No 2 segments with a common endpoint are collinear. Because if they're collinear, it'd just be a straight line. Right? That wouldn't be a polygon. They have to have some kind of bend in it. All right. I like to think of polygons are either, you can picture them, or you could say, hey, that's definitely not a polygon. Sometimes it's hard to explain why they aren't. We can try on these. But it's just easier to look at them and say, that's a polygon. That is not a polygon. So these are all examples of polygons. These are all examples of not polygons. These are all non-polygons. And let's go through why they're not. The very first one. In a polygon, you can't have this little overlap section. All right? It kind of cuts in on itself. It has to be something you can basically cut out of paper without having cut like a little triangle out of the inside. All right, so it can't have that little section there. The problem with the next one is it can't be curved. So it can't have curves. So that means a circle is not a polygon. And our third one can't be a polygon because it doesn't fit this explanation. It fits part of it. It says each segment must intersect exactly 2 others. So this one does intersect these 2. However, it says 1 at each endpoint. Both the intersections are at the same endpoint. It would have to be down here to be a polygon. All right, so none of those are polygons.
What was the first one again?
This one?
Yeah.
Oh, they're coplanar. It's just we have this overlap. See how it's intersecting?
Yeah.
We're intersecting here.
Yeah.
It's only allowed to intersect things that's endpoints.
Oh.
So here and here I'm okay. The problem is I'm intersecting somewhere other than my endpoint, so it is not going to be a polygon because I have too many intersections there. And honestly, I always feel like polygons, like you just kind of look at it and you're just like, that's a polygon. That's not a polygon. That's a polygon. That's not a polygon. And we'll do plenty of practice with it, so you shouldn't have to worry. Any questions about what makes a polygon a polygon? You've worked with these shapes before. All right, it's just straight lines put against each other, end to end, and that's going to be your polygon. No curves. All right, the next thing we're going to talk about is convex polygon. A convex polygon is a polygon such that, and if we look down there, convex, we have all our vertices pointed outwards, so such that no line containing a side of the polygon contains a point in the interior of a polygon. So convex means all of them are basically outside. All right, they're all pointing out. Concave, on the other hand, is when they come inside of the polygon. All right, this point is on like the interior. Like if I draw a circle around this, it's inside that circle. If I draw kind of like a circle around here, none of them would be inside that circle. So convex, everything kind of goes out. Concave, something's going to be bent in. All right. Convex, well, depends how you're looking at it, I guess. There's no way I can hand it. Convex, concave inside. All right. We're going to be mostly dealing with convex ones, and eventually we'll just talk about rules with convex because concave has their own rules. But convex is going to be our big guy. All right. Polygon classification. Since polygon means many sides, we're going to classify things according to the number of sides. Jacob almost died, I think. All right, so I listed all of them that you need to know. Well, you don't need to memorize them. On a test, if you're not sure of something, just ask me how many sides it has. But it's a good idea to get them down, generally know them so you don't have to ask questions all the time. And you'll see certain ones appear all the time. All right, and those are the ones you learn. But I'm pretty sure we know triangle, quadrilateral, 4, quad, pentagram, pent, that's 5. So these all, if you know the base words, you actually know every one of them. Hexagon, heptagon, octagon, nonagon, decagon, dodecagon, and anything else after that, we just say the sides. We'd say like a 20gon, a 25gon. Surprisingly, a lot of those actually have names. They're just so infrequently used that we just stick with. Once you go past dodecagon, you just kind of 13gon, 14gon. All right? Note the terms that we apply to triangles. Since a triangle is a polynomial, such as vertex and exterior angle, will also apply to a polynomial or a polygon. All right. So basically we're dealing with triangles, but they have more sides, and they become just polygons. All right, naming a polygon. When referring to a polygon, what we're going to do is we're basically going to list all of the letters in order. It doesn't matter where we start. It just matters how we continue on. So we're going to list everything with listing consecutive vertices. So consecutive vertices. So like I said, it doesn't matter where you start. It just matters what you pick next, and after that, and after that. So let's go ahead and just start with E. All right, so a way I could name this. If I was naming this, I could name it E, D, C, B, A. And that would be going basically clockwise, counting all the way around. I'm allowed to go the other direction as well. Or I could have E, A, B, C, D. And that would just be going the other way. It absolutely does not start. So I would put down or. We could do A, B, no. Yeah, we could do A, B, C, D, E. So this time I started way down here, and I just went this way and counted all the way around. Or any letter in any direction as long as you follow. So we have tons of different options to name this. So or dot dot dot, we're not going to list them all. Let's put a not example. Not, this would be not a good example. If I went like E, C, B, A, D. Because how we name polygons is basically how you would draw it. All right, and if I told you it was E, C, B, A, D, you would go E, and you would draw a straight line. And then you would go to B, A, and then D, which wouldn't be a polygon. All right? So you're basically naming it how you would draw it. Doesn't matter where you start, right? You'll have the same drawing if you start at the bottom. Same thing if you start at the top. You'll come with the same drawing as long as you do it in order. All right, questions about naming these? And we didn't have that problem with triangles because it didn't matter which order. You only had 3 things to choose from. You couldn't do them out of order. Right? There was no way to go across because your third one's right there. All right, so polygons is the first time we have to worry about it. All right, diagonals of a polygon. Diagonals of a polygon is a segment joining 2 non-consecutive vertices is a diagonal. So it's just going to be a segment joining a segment joining 2 non-consecutive. And they have to be non-consecutive because you have to be able to draw it. This would not be a diagonal. This right here is a diagonal. So this is a diagonal. And we just name it like a segment. A, D. Diagonal AD. So from this point, I could draw another diagonal. Sabrina, are you okay?
Yeah.
Okay. From this one, I could draw 2. From this one, I could draw 2. From this one, I could draw, well, we already covered 1. This one, we can draw 2. All right? So from each of these vertices, we can draw 2 diagonals from it. All right, now we're going to get to a pretty important thing that's going to keep reoccurring. All right, that is the sum of measures of angles. How many sides does a triangle have?
3.
Oh, I said 5. And how many triangles can you draw with one triangle?
4.
Oh, nice. You guys are way ahead of me. What's the sum of all my angles of a triangle? 180.
It's okay, he'll never understand.
So it must equal 4? Obviously. In math, if you see 2 numbers, you add them. At the end of the day, just add them. All right. Our next one, how many sides do I have in the next one? 4. Now, what I mean by triangles is from one vertex, how many diagonals can I draw? Actually, only 1. From this point, I only can draw 1 diagonal. But I'll have 2 triangles. Yes. Okay. I asked how many. Okay. I'm on board now. You seem so angry about not trying. Okay. Yeah. We have 2 triangles. You got me. All right. So.
What if there be 3? Because what do you do? What about like the other vertex?
I said from one vertex, how many diagonals can be drawn? It's only 1. So we're just going from one vertex. And I can split it into 2 triangles. All right, as soon as you try splitting it up more, well, now we're not dealing with this one's angles. We're dealing with interior angles as well. All right, so this one focuses on, well, this is 180 degrees, right? This angle plus this angle plus this angle equals 180 degrees. This angle plus this angle plus this angle equals 180 degrees. I feel like I'm missing some. What am I missing? No, it's just everyone's giggling.
We're giggling because other people are giggling.
Oh.
I guess.
Me too. All right, anyway. So there's two triangles. There's two triangles. Each triangle is 180 degrees. So that must mean the angle sum of this one would be 2 times 180 degrees, which equals 360 degrees. On our next one, if I pick one vertex, and I draw diagonals from it. This is 1, 2, 3, 4, 5 sides. 3 triangles. So it's going to be 3 times 180 degrees, which is going to be 540 degrees. Our final one, once again, if I draw from just one vertex, I'll have 1, 2, 3, 4 triangles. So I have 1, 2, 3, 4, 5, 6 sides. I have 4 triangles. And so that's going to be 4 times 180 degrees, which is going to be 720. Yes?
I counted 5 triangles.
I do not count 5. 1, 2, 3, 4.
Oh, I did it this way, so it's like I did this a triangle and then 1, 2, 3, 4.
Like I said, you have to start from one vertex, otherwise you're counting angles on the inside. It only can be the outside ones. It has to be from one vertex. Doesn't matter what vertex you pick, it is going to be 1. And these are all true. This is 180 degrees, this is 360, this is 540, this is 720 degrees. Notice this pattern though. 3, 1, multiply by 1. 4, 2, multiply by 2. 5, 3, multiply by 3. 6, 4, multiply by 4. If I had 7 sides, how many triangles could you draw? Without drawing it, just from this pattern, I could draw 5. Yeah. What if I have 98 sides? If I have 98 sides, how many triangles? 96. What if I have 364? This is important. I mean, if you guys missed this, this is huge. Let's say I have 364 sides. How many triangles can I draw? 362. So, however many sides we have, if I subtract 2 from that, that's how many triangles I have. Not only is that how many triangles I have, I want to multiply how many triangles I have by 180 to figure out how many degrees are in that given polynomial. All right, so that gives us the wonderful ability to get the sum of interior angles by just knowing how many sides a polygon has. So the sum of measures of angles, so this is for sum, adding them all up. The sum of the measures of all the angles inside a polygon with n number of sides is going to be take your sides, subtract 2, and multiply by 180 degrees. And that works for any polynomial. All right, so if I had, I don't remember if I put problems on. I don't think I did. Real quick here. So if I had, say, 103 sides, how many degrees would be inside that polygon? If I had 103 sides, what would I do? You just, yeah.
101 times 180, which would give you 18,182.
Yeah, you just take your number of sides, subtract 2, and multiply it by 180. That will get you the sum of all of them. That is a very important formula to know and remember, and I hope this giggle fit doesn't cause you not to know this. This is one of the most important things for this test. You forget this and you get a whole bunch wrong. All right, right off the top, you don't know this formula, you get a whole bunch wrong. Okay.
to like write that formula out, or does it matter? You know what I mean?
Like distribute it.
Well, like, yeah, sure. Like, in when we're like, solving it, you know what I mean? Do you want us to write formula and then like write in for the variables?
I would
Okay.
to make sure I know that because if you make a mistake, like let's say there's 9 sides and you actually you accidentally multiply by 6. You meant to subtract 2. At least I can see that you meant to subtract by 2. All right, a regular polygon. We're going to talk more about this tomorrow. A regular polygon is one that is equilateral. That means all sides are the same, and equiangular. That means all of the angles are the same. We'll talk more about that tomorrow. So the rest is going to be our worksheet. Let me bring up one of the problems really quick. Evan, can I see yours real quick? I'm just going to take a picture of it. Sorry. No.
I want to keep my eye.
You want to keep all your eyes?
Yeah, show you one.
That seems pretty... All right, in order to solve a lot of these, you have to know what is the sum of all the angles in here. Remember with triangles, we always knew it was 180. So I could take, if I knew 2 of them, I could subtract them away. So you're going to have to get the sum of all of the angles for a lot of these things. So all you'd have to do is count the sides. Robin, can you pick up your head real quick? Thank you. We count the sides, 1, 2, 3, 4, 5, 6. We do that 6 minus 2. We multiply by 180, and that will get what all of these angles need to measure. All right, you're going to have to do that for almost all of them. Okay? All right, thanks. All right, so let's go ahead and get started.